Hey precalculus students. So in this video, we are going to be reviewing long division and specifically long division with polynomials. So this is something that you were exposed to last year, but it is important that we review it before I obviously just expect that you know how to do it. So you received this capture sheet today in class, and this is your homework assignment to be watching this video. So I encourage you to make sure that you have the capture sheet you received in class out as we're going through this. And this video will pause in different places and ask you different questions. So you're going to want to make sure that you're keeping up with it. And then the very last question will be one that you're doing on your own, and we will review in class when I see you next. So let's start with just long division with numbers, right? And this probably takes you way back to I actually can't tell you when, but way back in your math career. So when we're doing long division with this, right, and please don't pick up your calculator, we want to think about expressing it this way, right? 7,421 divided by 5. And hopefully you remember that one of the first things you do is you're trying to figure out how many times does 5 go into 7. So really what you're saying is 5 times what gives me 7, right? It's not a nice number in this case, right? So, 5 goes into 7 one time. Okay, so let's see where that gets us. 1 times 5 gives me 5. And then we're going to go ahead and subtract. 7 minus 5 is 2, and bring down. Did not give myself enough room, but that's okay. So now we do it again. Well, 5 goes into 24 how many times? 5, if you think about it, times 4 gives me 20. If I do it a fifth time, I'm over. I don't want to be over. I want to be under. 4 times 5 gives me 20. I'm going to go ahead and subtract. I'm going to write it up here, so please bear with me. And I would get 4, and then I'm going to go ahead and bring this down. I'm going to bring the 2 down. Okay, 5 goes into 42. It doesn't go in evenly, right? But 5 times 8 gives us 40. So we'll go with that. That's close. 8 times 5 gives us 40. Subtract gives us 2. And I'm going to bring down this 1. All right, that's my last number. 5 goes into 21 4 times, still not evenly. 4 times 5 gives us 20, and I'm left with this right here, right? Like I'm done. I've got nothing else to bring down. That is our remainder, right? So what I actually got just now was I got 1,484 with a remainder of 1, which I can express as, I'm going to add 1/5 to this. Remainder over divisor. Right? 1/5 is actually equivalent to 0.2, right? 2/10. So I get this, right? So if you were to do this in your calculator, which you're not, I get this right here, right? Some of you guys might be thinking like, didn't we do this and we like would add a 0.0 and you would then like bring down the 0. And you totally can, right? You're going to get that too. That's not going to work as nicely for polynomials. So I do want to show you this, right? Like it's the remainder. It's how much am I left with? Well, I have 1/5. I'm actually 4/5 away from getting to a whole number. So this right here didn't divide evenly. If you take it back to what we've been talking about, right? With like, we've been factoring. Is 5 a factor of 7,421? No, it's not a factor, right? If it didn't divide evenly, it was not a factor. Just like 2 is not a factor of 5, right? You get 2.5. It doesn't divide evenly. Okay? So let's see how this applies to division. So we're going to do the first one, and I'm actually not really going to pause the video at all for this one for you guys. So I want you to just work along with me and then be prepared for me to start pausing the video and asking some questions as we proceed. So, number one, the first thing, like this is division, right? So just like I did before, I want to start by expressing it like this. X squared minus 3x plus 1 divided by x minus 1. Our focus, like this is so minuscule, this minus 1, our focus is just going to be on this x. It's not that this minus 1 doesn't matter, but this is going to be our focus. So just like we did before, I'm going to ask you, how many times does x go into x squared? Or I'm saying x times what gives us x squared? We'll have to multiply it by x, right? X times x gives us x squared. X times x gives us x squared. X times negative 1 gives us minus 1x. So I'm going to go ahead and, just like we did with numbers, subtract. X squared minus x squared cancels. That's what we want. Negative 3 minus negative 1. Be careful here. It's a double negative. If you want to write the subtraction sign here also, negative 3 minus negative 1. Negative 3 minus negative 1 is negative 2, right? Be careful with that. You're adding 1. So negative 2x, they're like terms, and go ahead and bring down the 1. Okay, so now let's do it again. X goes into negative 2x. What do I have to multiply by? X times negative 2. Negative 2 times x gives us negative 2x. Negative 2 times negative 1 gives us plus 2. And just like we did before, let's go ahead and subtract. Negative 2x minus negative 2x cancels. 1 minus 2 gives us negative 1. I got nothing else to bring down. So this number, this negative 1, is known as our remainder. It did not just divide evenly. And our answer, our final answer, is going to be x minus 2 plus negative 1 over x minus 1, right? The fraction that's left. If you want to express it this way and say x minus 2 minus 1 over x minus 1 because it's a negative, that's fine. Okay, so this is our final answer. Okay. So let's go ahead and try number 2. Right, so again, I'm going to start by expressing it the same way I just did. 2x squared plus 11x plus 5 divided by x plus 5. Our focus will be x. So I have a question. How many times does x go into 2x squared? What do you need to multiply x by? Hopefully you said by 2x, right? 2x times x gives us 2x squared, which we want. We want these to cancel. 2x times 5 gives us plus 10x. Then we'll go ahead and subtract. These cancel. 11x minus 10x gives us x, and we bring down the 5. How many times does x go into x? 1 time, so plus 1. Now we're going to multiply 1 by both of these terms. 1 times x gives us x. 1 times 5 gives us 5. What is this value called? This is called our remainder. What does it mean to have a remainder of 0? A remainder of 0 means that x plus 5 was a factor. Is a factor. It divided evenly. I didn't have anything left over. It's like dividing by 4 by 2. I don't have anything left over. 10 by 2. It goes in evenly, right? So our answer, our quotient, is 2x plus 1. There's no remainder. Okay? Let's keep going and let's take a look at number 3. So hopefully you're already writing on your paper, and you maybe have this. Do we see any issues with this? This one doesn't have a squared term. So what happens when I go to start dividing? X goes into x to the third, x squared, but where do I put that? Well, let's put it and let's see, x squared. So then I get x to the third minus 8x squared. These don't line up. They're not like terms. So let's back up for a minute. We're not wrong. We just can make this a little bit better. So let's go ahead, and even though it doesn't have an x squared term that we see, it just means that the coefficient is 0. So let's write that in, right? Let's account for that like empty space. And now let's keep going, right? So we already said x squared. And then we've got that's x to the third minus 8x squared. And now I'm dealing with things that are like terms, which is good. We want that. 0 minus negative 8. What's that? 8x squared. Bring down the negative 64x. How many times does x go into 8x squared? 8x times. 8x times x gives us, oh no, I'm going to go, oh no. 8x squared minus 64x. They cancel. What's the remainder? 0. There isn't one. Right? Our answer is x squared plus 8x. X minus 8 was a factor. Right? If it didn't, like number 1 didn't divide evenly, it wasn't a factor. We got a remainder. Okay? So let's look at those ideas a little bit closer, like what we just said, right? So now number 4 and number 5 are a little bit more application based. So number 4 is saying we want to use long division still to determine if x plus 1 is a factor. What is something you notice about how this is written? Hopefully you're thinking that it's missing the x squared term. It's okay if you weren't. Now maybe you are. So if it's missing it, I still want to include it just like I did on the problem before. What is the coefficient when I write it? 0. 0x squared, right? So let's go ahead and divide these, right? We're going to know if it's a factor if what is true. If the remainder is 0, right? This is really basically as saying, is there a remainder? Is the remainder 0? Okay, so x to the third plus 0x squared, don't forget that, minus x plus 4. Divided by x plus 1. X goes into x to the third how many times? X squared. Gives us x to the third plus x squared. Subtract. Cancels 0 minus 1. Negative x squared, or negative 1x squared. Bring down that negative x. X goes into negative x squared. Negative x times, or negative 1x times. X, that's negative x squared. Minus x, oh my goodness, look, they both cancel. Bring this down, and I get 4. Well, x can't go into 4 any times, right? So this right here is our remainder. So what is the answer to this question? Is it a factor? No. We got a remainder. Right? Our answer, if we were going to divide this, which we did, we actually get x squared minus x plus 4 over x plus 1. Like it didn't divide evenly. Right? It doesn't divide evenly, so no, it is not in fact a factor. Let's take a look at one more. So in this last one that we're doing together, you've got one down here on your own, we're being told that x plus 3 is a factor. So when I divide by x plus 3, I should get a remainder of what? 0. Right? And so now we want to use long division to reduce this to a quadratic and then write f of x in factored form. Oh, this is tying a lot of stuff together. So let's go ahead and start by dividing. 3x to the third plus 5x squared minus 11x plus 3 divided by x plus 3. X goes into 3x cubed, right? 3x squared times. Now multiply. 3x squared times x gives us 3x to the third. If it didn't, we would have known we made a mistake. What's 3x squared times 3? 9x squared. Subtract. Cancels. 5x squared minus 9x squared, negative 4x squared. Bring down the negative 11x. X goes into negative 4x squared, negative 4x times. Gives us negative 4x squared, good, minus 12x. Subtract. I'm going to have to go up here again. I'm on a roll. Negative 11 minus negative 12. Careful. What is that? That's just x. Negative 11 plus 12 is really what you're doing there, right? Or 12 minus 11. And then I'm going to go ahead and bring down the 3, which hopefully you see what's about to happen. X goes into x one time. And then we get x plus 3 with a remainder of 0. Right? Good. It told us it was a factor. So right now we have this. We just divided. If I were to take x plus 3 and multiply it by 3x squared minus 4x plus 1, I would get f of x. Right? I factored it out. It's still, I don't want to get rid of it. Well, we can use some of our factoring skills that we've been working on to actually factor this even further. Right? Don't drop the x plus 3 and leave it. What does this factor into? We can say 3x and x. It's got to be 1 and 1, right? And for it to add to a negative 4 and multiply to a 1, they both have to be negative. They both have to be the same side to multiply to a positive 1. So let's just check. Negative 3x minus 1x, great, 4x. So we reduced it to a quadratic, right? When we divided, we pulled out a linear factor right here. That was our linear factor. We are left with a quadratic, a second degree. We then used our knowledge of factoring to factor that further. And now we have f of x in factored form. How cool. Right? Awesome. So these 4 and 5 were a little bit more of applications, not just the straight up long division, to kind of see where things tie in. But if you need to go back and rewatch anything, please do. You guys have this problem now to try on your own, and we'll be going over this one in class. So thank you so much for watching, and hopefully this gave you a decent review of long division. If you need more practice, please reach out so that you can get more practice before we come back together and apply this skill. Thanks, everyone. See you next time in class.